Hello friends, welcome to Risingpearl.com. Today we are talking about series 12 where we are learning a great deal on areas related to circles. This is webisode number 8. Friends, today we are going to focus on areas of common geometrical figures. Now these are figures like circles, triangles, rectangles, so on and so forth that you have learned earlier. The reason we want to do it right now is from webisode number 9, that is from next webisode onwards, we are going to take a look at shapes of figures that involve two or more of these common geometrical figures. So before we start looking at areas of those complex figures, let's revisit quickly the areas of some of the common figures that we have learned over the years. Now, area of a circle. So if the radius of this circle is r, and area of a circle is the one which is highlighted in blue, then we know that area of a circle is equal to pi r square, where r is the radius of the circle, and the value of pi is a rational number. If nothing is given to us, we are going to use pi equals 22 by 7, and in a decimal form, if we have to use it, we are going to go with 3.14. So this is the area of a circle. Now let's talk about area of a triangle. So I have drawn here a triangle. Now if you want to find out the area of a triangle as highlighted by the blue portion, then we know that area of a triangle is equal to, if this distance, that is, if we drop a perpendicular from one of the vertex to the other side, and if this perpendicular distance is a, that is, if this measure is a, and the base on which the perpendicular is dropped, if that measure is b, then area of a triangle is given by half a times b. So this is how we find out we write the area of a triangle: half the height or the perpendicular distance times the base on which the perpendicular is dropped. There is another formula for an area of a triangle, which is that if we know the sides of a triangle, let's say this is A, this is B, and this is C, that is the length of each of the sides. If we know the three lengths, that is length of each of the sides, then we have seen applying Heron's formula, we can write the area of the triangle as square root of s times s minus a, s minus b times s minus c, where s is semi-perimeter. Perimeter of this triangle is the length. So if you start from here, it will be b plus c plus a, right? But s is a semi-perimeter, which is half the perimeter. So a plus b plus c divided by 2. So that is the value of s. Then the area of this entire triangle will be equal to square root of s times s minus a times s minus b times s minus c. We have seen this in our earlier grades as well. Let's move on. Now we want to talk about one special case of triangle, which is an equilateral triangle. Now let's say if each of the sides is of length a. We know that in an equilateral triangle, each side is of the same length and each angle is 60 degrees. So if you look at this particular triangle, this height will be, let's say if this is x, we know that area of any triangle equals to half times x times a, which is half times the perpendicular distance times the base. Now what is this height x? So if you look at the triangle, let's just, if you look at triangle, let's just name this, say a b x. If you look at triangle ABX, this is 60 degrees. So if you look at sine 60 degrees from trigonometry, if we look at sine 60 degrees, sine 60 degrees is equal to the opposite side, which is AX, or the value of which is x divided by the hypotenuse, which is a. Now sine 60, we know, friends, is square root 3 by 2. So from here we see that x is equal to square root 3 by 2 times a. Now going back to the area of a triangle, which is given by this, so let's just keep this on the side. So area of the triangle will be half x, which is square root 3 by 2 times a, which is this is x, times the base, which is this a. Or in other words, it will be square root 3 by 4a square. So this is a special case where a triangle is an equilateral triangle. Then if you know the length of the side, all the sides are equal length, then you can write the area of equilateral triangle as square root 3 by 4 times a square. Now let's move on to area of a rectangle. If this length is a and if this length is b, area of a rectangle we know is a times b. This is the area of a rectangle highlighted by the blue portion. Similarly, area of a square, if this side is a, then this is also a, because all sides are equal in a square. So area of a square will be a times a, or it will be equal to a square, where a is the side of the square. This will be the area of a square. Now let's take a look at area of a parallelogram. So how do we find out the area of the parallelogram? Now the parallelogram here is the area is highlighted in blue. The area of a parallelogram will be, friends, so if you drop a perpendicular from one of the vertex on the other base, and if this perpendicular, if this length is a, and if this base is b, then the area of the parallelogram is a times b. And whenever it comes to any diagram which has 4 sides, right, you can actually find out the areas of each of those diagrams by breaking them into 2 or more triangles. So for something like this, if you were to join this vertex and this vertex, and then you can see that then the area of half of the triangle will be half a times b, but there are 2 such triangles, and these 2 triangles will be congruent triangles. So the area of the entire parallelogram will be half a times b plus half a times b, or it will be equal to a times b. Area of a rhombus similarly will be equal to, if you join the 2 diagonals, the diagonals will intersect at 90 degrees. So let's say the length of this diagonal is a and length of this diagonal is b. So then the area of a rhombus will be half, it will be half a. Actually, let's do one thing. I think instead of trying to find out, I am trying to figure out what exactly is the area of a rhombus. So why don't we quickly find out, like we discussed, by breaking this into triangles a, b, c, d. Let's say they intersect at o. So if I look at this particular triangle a, b, d, so area of triangle ABD, let's write it here, area of triangle ABD will be equal to half, this will be a by 2, half times a by 2 times this is b, or a times b by 4, which will be area of ABD. Now ABD will be exactly, we can prove that ABD is congruent with CBD. So the area of the entire rhombus will be this times 2. So the area of the rhombus will be, the required area will be AB by 4 times 2, or it will be AB by 2. In other words, it will be AB by 2. So let us just separate this out. So it will be A times B by 2, where A and B are the 2 diagonals. That will be how, that's going to be the value for area of rhombus. Similarly, area of a trapezium, if the parallel sides, if the length of the parallel sides, let's say this length is A and this length, which is the other parallel side, is B, and if they are separated by distance h, which is the height between the parallel lines, Similarly, area of a trapezium, we can prove that it will be half times the height times A plus B. You can do it very easily simply by joining these two vertices and finding out the area of the two triangles one by one, and then simply by adding them you will see area of a trapezium equals this value. Now let's talk about area of regular polygon. In the last webisode, the last question, which was one of the most complicated questions that we kind of saw during the questions on sectors and segments, I'm going to include that link below. We came across a regular pentagon. So now how do we find out areas of regular polygon? Now let's talk about what is a polygon. Polygon is a plane figure that has at least 3 straight sides and angles. So if it has less than 3, then we know that if you have 2 straight lines, you actually have an angle. You do not have a closed shape or a closed figure. So you need to have at least 3 sides and angles. That means a triangle or more, right, in terms of number of sides and angles. So that is a polygon, which is a plane figure that has at least 3 straight sides and angles. So what is a regular polygon? We are talking about regular polygon. A regular polygon is nothing but it is a polygon that has equilateral, equal length sides, and that is equiangular. That means they have all the angles are equal. So polygon is any closed figure that has at least 3 straight sides and angles, and regular polygon is where all the sides are equal, of equal length, and all the angles are equiangular. Now let's take a look at how do we find out area of any regular polygon. Polygon, if we were to find out the number of sides, if we write them by n, so it will be 3 or greater, so 3, 4, 5, etc., etc., right? So the area, like we saw in the last webisode, last question, it will be half times perimeter of the polygon times apothem. Now what is apothem? Apothem is the length of the line drawn from the center of the regular polygon at right angles to any one of the sides. So in other words, let's take a look at a regular polygon. So if this is a pentagon which has 5 equal sides, so let's say each of these sides is of length x. So we have a regular polygon. We have a regular pentagon. Pentagon is where number of sides is equal to 5. Then area of a regular polygon is the one highlighted in blue. So the way we are going to find out the area is that we actually have to drop a perpendicular. So if this is the center of the polygon, we drop a perpendicular like this. If this length is a, and if each of the side is, like we said, x, then area of this pentagon will be equal to half the perimeter. Perimeter will be 5x, where x is the number of sides, times a, where a is the apothem, or this is a perpendicular drop from the center to any one of the sides. So similarly, friends, if you have a hexagon, in this case, so the area for the hexagon will be equal to, so this is the center of the hexagon. If we drop a perpendicular, and if this measure is a, and if each of the sides is x unit, hexagon has n equal to 6 sides. So because it's a regular hexagon, all of these are equal. So the area will be half times 6x, where x is the measure of each side, times a, which is the perpendicular distance from the center to any one of the sides. So friends, these were some of the basic shapes, figures that we have learned over the years in our earlier grades, earlier webisodes as well. And how do we find out the area for each of these common figures? So, and what are the formulas to finding the areas of these figures?